So far, we have understood encapsulation as the first pillar of object-oriented programming. We have also discussed pillar number 2, which is abstraction, and pillar number 3, which is inheritance. The pillar 4, which is the final pillar of object-oriented programming, is polymorphism. Polymorphism is constituted of two terms, poly and morphism. Morph basically means form, shape, and poly means many. This word has been derived from Greek terminology. And hence, polymorphism, as the name suggests, many forms, basically means a same object can behave differently in different conditions. We will see this in the code example very shortly. First, let us understand it theoretically. So this is like extending without if-else chains. The problem is if-else chains based on type checks become unmaintainable as new types are added. Suppose Hindi is a type of language, then English is a type of language. And as the world evolves, even let's say Sanskrit becomes a type of language. So if else ladder, if else chain will keep growing. One case will be for English, one case will be for Hindi, one case will be there for Sanskrit. The solution for this is use polymorphism to let objects handle their own behavior through method overriding. Method overriding is used extensively in polymorphism. And with the help of method overriding, polymorphism lets the objects handle their own behavior. Behavior means methods. This we have already discussed when we discussed objects and classes. Now, in the interview, you have to win the interviewer's heart by saying adding a new payment method should not require modifying existing code. We just add new class. This is also known as open close principle, one of the solid principles. For example, replace if type is this, then do this, else if type is this, then do this, with just payment method dot process. Now, let us first take an example of how polymorphism works by taking example of this snippet. So we have several payment methods available. You can pay via credit card, you can pay via cash, via debit card, or if you are in India, you can pay via UPI as well. So let's take an example where I will be creating the parent class as payment method. This payment method will be having very simple attributes. Instead of adding attributes, we can just write process. And this method will do some processing logic, for example, deduction of the amount from the payee and then crediting it to payer. But we can just write for now system.out.println processing payment. That's all. This payment method is kind of abstract because it cannot exist on its own. Some of its concrete objects, concrete instances will exist, UPI, credit, debit, cash. So I will be making this as abstract class for now. You can also make this as interface and define the method as default. But here for simplicity, I have made this as abstract class. Now let us quickly create two new classes. One is the debit and one is the credit. Each class will be extending the payment method. And this method they will be overriding. So when we are in the debit class, it will say processing debit payment. And when we are in the credit class, it will say processing credit payment. Or you can write processing payment via credit card or debit card. That should be fine. So here we have basically created one parent class payment method, which has one method process. And this is overridden in two of the subclasses debit and credit, which print different messages. Now in the main class, I can write like this. Payment method, and then payment method 1 is equals to new payment method. This is abstract class, so I cannot create instance. So I will rather create debits. and then credits. Now in interview, you will write like this, full names. So you will write payment, or let's write debit and credit only. Now if I do debit dot process and credit dot process, what should be the behavior? Obviously, debit dot process will call debits process method, which is printing processing debit payment. Similarly, for credits object, it will be printing processing credit payment. Let's try to run and then see what happens. So as expected, they are printing processing debit payment and processing credit payment. Now, if I just define one variable and I move some of the statements up and down, what do you think should be printed? I just created one variable, payment method. First of type debit. Once processing is done, I am assigning the same variable as new instance of credit. So it references two objects, debit and credit, in different points of time. And then I am processing on each of those. So ideally, this should also print the same thing. So on execution, you find that output did not change. Why? On line 4, I have written payment method dot process. And if I highlight this, you will see on line 6, the entire text is highlighted as well. That means both the lines are same. But both the lines are printing different things at runtime. Although at compile time, you see line 4 and line 6 are the same, ditto same. But at runtime, the behavior changes. And hence, polymorphism is a runtime behavior where at different points of time, the same behavior starts behaving differently. This is because first payment method was referring an object of debit type. But this reference was changed on line 5 where I started payment method to point to an object of credit type. And hence both the lines 4 and 6 behave differently. And this is the idea of polymorphism.